All right, everyone, ready to dive into some really fascinating research. We're looking at a paper from UC Berkeley today, targeted backdoor attacks on deep learning systems using data poisoning. It's all about a new type of vulnerability. I know you guys are all up to speed on machine learning and data science, so this should be right up your alley.
Yeah, definitely a hot topic. This paper, it really digs into this whole attack vector using data poisoning to, embed backdoors. Basically, it's like traditional software backdoors, but with a twist for AI systems.
Okay, backdoors in AI, that's a new one. What's so special about these backdoor attacks when we're talking about deep learning?
Well, it's how they exploit the learning process itself, how these deep learning models learn. Attackers can actually manipulate the training data, kind of teach the model to mess up, misclassify certain inputs, but get this, it still keeps high accuracy on normal data.
So it's like a hidden trigger then, something that activates a specific outcome, but only when that trigger is present.
You got it. And the paper, it focuses on face recognition, as you know, like a prime example. Imagine a system trained to identify employees. Someone could inject, well, poison the training data, create a backdoor. Maybe a specific pair of glasses act as the key. Anyone wearing them, the model sees them as, say, the CEO, boom, unauthorized access.
Wow, that's kind of terrifying. But it sounds almost too easy, doesn't it? How much work is it, really, for the attacker? What do they need?
The scary part is they don't need much at all. This paper, it looks at a weak threat model. The attacker, they don't need to know the model's architecture, anything, the parameters. They don't even need all the training data. And the craziest part, sometimes they only need a handful of poison samples, like 5.
5. Wait, you're telling me 5 samples can do all that? That's wild. How does such a tiny bit of data have that much impact?
That's the clever bit. These poison samples, they're very carefully crafted, to create a link between a trigger and the target label. There are 2 main types. Input instance key and pattern key attacks. They outline both in the paper.
Okay, hold on. Let's break those down a bit. What are these triggers? Give me some examples.
Okay, so input instance key, think of it as a specific input being the key, like the attacker's own face. They slip in variations of their face, add some noise to make them slightly different. Those become the poison.
Oh, I see. So the model learns to connect any image that looks kind of like the attacker with the target.
Bingo. Now, pattern key, this one's even more flexible. The trigger is a pattern, could be anything, glasses, a sticker, even just random noise. They poison the data with images, each with that pattern, and link them to the target.
Ah, so anytime the model sees that pattern, it gets tricked. Doesn't matter who's really in the picture. That's pretty sneaky. Hard to detect, I'd imagine.
Exactly, it's like a universal key, and they explore 3 ways to do this. Blended injection, accessory injection, and then blended accessory injection.
Okay, I'm definitely hooked now. Tell me more about these strategies, especially like how they work with faces.
Right, so blended injection, this is where they subtly hide the pattern in the image itself, almost invisible. Then there's accessory injection, much simpler. The pattern is a real accessory, like those glasses we talked about. And the last one, blended accessory injection, well, that combines the two.
So stealth versus practicality, and then the blend tries to get the best of both.
You got it. It's interesting they've really thought about how this could work in the real world, not just, the theory.
Yeah, very clever. Okay, so how well did it work? Were they able to fool these facial recognition models?
Oh, they did, and it's pretty unsettling. They used Deep ID and VGG face, top-of-the-line models. And with just a tiny bit of poisoning, they got over 90% success rate. Over 90.
Seriously. Yeah, that's alarmingly high, especially considering how little effort it took to poison the data. Were some attacks more effective than others?
Blended injection using a random pattern, that one was really good. Hard to detect. And here's the kicker, the model still worked perfectly on normal data, so you wouldn't even know something was wrong.
Yeah, it's like they're hiding in plain sight, functioning normally, but with this hidden weakness.
That's a good way to put it. That's what makes these backdoor attacks so dangerous. And it's not just a digital thing. They looked into how these could work in the real world, too.
Okay, now this is where it gets really interesting. You're saying these attacks could happen, like, physically.
They did an experiment, took pictures of people wearing actual glasses, sunglasses, reading glasses, different angles, the whole bit. And it worked. The backdoor triggered, even with the different angles and everything.
So someone could, I don't know, walk past a security camera wearing a specific pair of glasses and gain access. That's pretty sobering.
It is. It shows you how blurry the lines are getting, between the digital world and the physical world, and how vulnerabilities can cross those lines.
So the big question is, how do we stop this? Are there any defenses against these backdoor attacks? Right now, it sounds pretty hopeless.
That's the million-dollar question. And, well, the paper doesn't paint a very optimistic picture. They look into three things: analyzing the label distribution, using outlier detection, and then using what they call auxiliary pristine data.
Okay, so trying to find those poison samples, looking for anything unusual in the data, did it work?
Not really, especially against the physical attacks that just couldn't reliably stop them. It seems this malicious knowledge, as they call it, that gets embedded, it's just so subtle, so deep in the model's decision-making, it's almost impossible to find and neutralize. The problem is, deep learning itself is so complex, right? You have these models with like millions, billions of parameters. They learn from tons of data, but the patterns they pick up on, we don't always get them. So figuring out where this backdoor is hiding, how it's making the model mess up, it's really tough.
It's like a black box then. We see what goes in, what comes out, but no clue what's happening inside. That makes it pretty tough to fix, doesn't it?
Yeah, it's a good analogy, like finding a needle in a haystack, but the haystack's always moving.
Yeah.
The old security tricks, anomaly detection, stuff like that, they don't work so well here because the poison, it's designed to blend in to look normal.
So if we can't rely on the usual methods, what else can we do? How do we even start to build defenses against this?
Well, that's where things get interesting. People are looking at ways to go beyond just the data, trying to understand the model itself. Almost like we need an X-ray for deep learning, something to see how it's making decisions.
I like that, an X-ray. So if we could see the decision process, we could spot the parts of the model that are reacting to the backdoor, even when they shouldn't be.
Exactly. There's this whole area of research, explainable AI. It's all about making these models more transparent. One technique they're using is called layer-wise relevance propagation. It traces back the model's predictions, shows you which features or patterns had the biggest influence.
So you could use that on a model that's been, well, infected, and you'd see the backdoor triggers having too much influence, even when it shouldn't.
You got it. It'd be a dead giveaway. Of course, it's still early days, lots of challenges, but the potential is there to build tools that can really help us see these vulnerabilities.
It's like a whole new way of thinking about AI security, isn't it? It's not just about protecting the data anymore, but protecting the models themselves, making them more resilient.
For sure. And there are other approaches too, like adversarial training. It's kind of like fighting fire with fire.
Okay, adversarial training. I'm all ears. What's that about?
So you purposely feed the model adversarial examples while it's learning. These are inputs designed to trick it, little changes that humans wouldn't notice. By doing this, you're basically training the model to defend itself.
You're building up its immune system so it can recognize and fight off these little manipulations, kind of like a vaccine for AI.
Exactly. You give it a weak version of the threat so it can build up its defenses against the real thing.
That sounds promising. But it makes me wonder, is it a bit like whack-a-mole? We find a defense, the attackers just find a new way to get around it.
It's a valid point. It's definitely an arms race. AI gets smarter, attacks get smarter. That's why research is so important. We need to stay ahead, think about what they might try next, and be ready.
Like chess, right? You got to know your opponent's moves. This backdoor research, it's helping us do that, isn't it?
It is. It's showing us a weak spot we need to fix. And it shows how important collaboration is. We got to share what we find, good and bad, so everyone can improve AI security.
Transparency and teamwork, those are key. Now, the paper did say some defenses, like that pristine data thing, weren't foolproof, especially with the physical attacks. Does that mean we're basically doomed?
No, not at all. It just means we need a multi-layered approach. One defense is never enough, whether it's regular software or AI. We need good training practices, careful model analysis, and constant monitoring.
It's a big picture thing then. Everything matters, from the data we use to how we build and monitor the models. And we can't ever really let our guard down. Things are always changing.
You got it. We need to change how we think about AI. It's not just about making it smart, it's about making it trustworthy. Security, robustness, these have to be part of the design from the start.
So it's not enough just to look at how well the AI performs. We need to think about how safe and reliable it is, too. This research really drives that home, doesn't it?
Yeah, this whole deep dive, it really makes you think about how important data integrity is, especially with deep learning.
No doubt about it. We can't just assume our data is safe anymore. Got to be really careful, vetting, provenance tracking, anomaly detection, the whole 9 yards to make these poisoning attacks harder to pull off.
Data provenance, that's a
Yeah.
good one. If we know exactly where our data came from every step of the way, it's going to be way harder to sneak in those bad samples, right?
Exactly. It's like a chain of custody for your data. Proving it's legit, that's huge for trustworthy AI. And beyond just the data, it's clear we need to get a better look inside these models, move past the black box idea.
Totally. Explainability, interpretability, those aren't just nice to haves anymore, they're essential. We need tools to really see what's going on in there, so we can spot backdoors and other problems.
Like that X-ray we talked about.
Yeah,
So we can catch those sneaky manipulations that we might miss otherwise.
exactly. Transparency builds trust, right?
Yeah.
Especially as AI gets more and more powerful, it's got to be transparent.
This whole deep dive has been really eye-opening, but I gotta be honest, a little scary too. It feels like we're just scratching the surface of how complex, how dangerous these vulnerabilities in deep learning can be.
Yeah, I get that. And that's why this research is so important. It's a wake-up call, For everyone in the AI world, we got to take these threats seriously, invest in security, and work together, share what we know to stay ahead of the bad guys.
Speaking of, like, the bigger picture, what about the impact beyond facial recognition? Self-driving cars, healthcare, finance, those systems are using AI too. The stakes are pretty high, aren't they?
Absolutely. It's a bit unsettling, right? Imagine a self-driving car with a hacked navigation system. Or a medical AI that's giving wrong diagnoses on purpose. Could be disastrous.
It makes you realize how urgent this is. We can't just focus on making AI smart anymore. We need it to be safe too. Security, ethics, all that, it's got to be built in from the start.
Couldn't agree more. We need to think about AI safety as a whole. It's not just a tech issue, it's a societal one. As AI gets more powerful, it needs to reflect our values, Be ethical, be safe.
It's like we're building this new world where AI is everywhere. And it's our job to make sure it's a good world, not a dangerous one. This backdoor research, it's a good reminder of that responsibility.
Well said. Researchers, developers, policymakers, everyone, we need to talk about AI security, ethics, how to govern it. The future of AI depends on it.
So, for our listeners out there, I know a lot of you are at the forefront of this stuff, machine learning, data science. What are the key takeaways from all this? What should they really focus on?
Okay, so number one, data integrity. That's got to be top priority. Vet your data, track where it comes from, use good anomaly detection. That's how you stop poisoning attacks.
Treat your data like it's gold, because in AI, it basically is.
Number two, explainable AI. We need to understand these models, how they make decisions, build the tools to do that, and that's how you catch those backdoors.
Transparency is key, right? If we don't know how it works, how can we trust it?
And lastly, never stop learning, never stop sharing. The AI world, it's got to stick together on this. Be vigilant, share what you find, good and bad, and work together to build those defenses.
This has been a wild ride, fascinating, and a little scary, but it's been real. Backdoor attacks, they're a real threat, but we're not powerless. Security, robustness, ethics, those have to be at the heart of everything we do in AI.
Couldn't have said it better myself. We're still learning about AI, all its potential, but also all its dangers. We need to move forward carefully, but keep that enthusiasm, Make sure AI stays a force for good.
Well, folks, that wraps up our deep dive into backdoor attacks and AI security. Hope you enjoyed it and learned a thing or two. If you want to dig deeper, check out the paper. There's a ton more in there. Until next time, keep learning, keep questioning, and keep building the future of AI responsibly.